Let's talk about some group 4 elements.
Group 4 elements,
Yes.
also known as the carbon. Got it. Group 4 elements are known for having a +4 oxidation state, with carbon and silicon being key players. Carbon's versatility in forming bonds and silicon's significance in electronics make them fascinating. Your thoughts?
Okay, let's talk about the general properties of these elements. Let's talk about their electronic configurations going down the group. Can you comment on that?
Sure. In group 4, the general electron configuration is ns2np2. As you go down the group, from carbon to silicon, germanium, tin, and lead, the number of electrons increases, resulting in more electron shells. This leads to a gradual decrease in ionization energies and electronegativities, reflecting the group's metallic character.
Okay, so what happens when it comes to reactivity going down the group? Does it increase? Does it decrease?
Reactivity generally increases as you move down group 4. For nonmetals like carbon, reactivity is higher at the top due to their ability to form covalent bonds. For metalloids and metals like tin and lead, reactivity increases down the group since they are more willing to lose electrons and act as reducing agents.
So you're saying there's a general increase in reactivity going down the group?
That's right. There's a general increase in reactivity down the group, especially for the heavier elements like tin and lead, which are more metallic and readily lose electrons.
Okay, so let's talk about something called the inert pair effect. How is this related to the chemistry of group 4 elements?
The inert pair effect is more pronounced in the heavier group 4 elements like lead. It refers to the reluctance of the s electrons in the outermost shell to participate in bonding. This makes lead more likely to form Pb2+ rather than Pb4+, unlike the lighter members of the group, which more readily use all 4 valence electrons.
Okay, so what causes, may you repeat on what causes this inert pair effect to be stronger with the heavier elements?
The inert pair effect is stronger in heavier elements due to increased nuclear charge and greater shielding by inner electrons. This causes the outer s electrons to be held more tightly and less available for bonding, making heavier elements like lead more inert in their +4 oxidation state.
Is this also related to the arrangement of electrons, the SPDF notation?
Absolutely. The inert pair effect ties into electron configuration. In heavier elements, the s electrons are more shielded by filled d and f orbitals, referred to those s electrons being less involved in bonding. The f orbitals, in particular, contribute to the shielding effect, making the inert pair effect more significant.
Okay, can you comment on the reactivity or the reactions of the oxides of these elements?
Sure. Reactivity of oxides in group 4 elements varies. Carbon forms CO and CO2, with CO being a reducing agent and CO2 showing acidic properties. Silicon dioxide, SiO2, is acidic, while germanium dioxide, GeO2, is amphoteric. Tinium and lead oxides, SNO, SNO2, range from amphoteric to basic, with increasing tendency to act as bases down the group.
Okay. May you also comment on the issue of hybridization of orbitals? Carbon has a tendency to have hybridized orbitals. Is this particularly a property of just carbon, or all these elements in group 4 do the same?
Carbon is indeed well known for hybridization, forming sp3, sp2,